guys, and welcome to exam prep video on consistency. So this is going to be a quick one. This is part 2 of consistency. We've solved the question that is similar to this one. So I want to show you a much more quicker method of approaching the same problem. So if you're given a problem like this, to find the value of k for which the following equation are consistent. So you want to determine the value of k for which these equations are consistent. So we are going to dive into the solution like this. Now, all you just need to know is that for this system of equation to be consistent, then the determinant that is formed by the coefficients of this system should be equal to 0. So determinant of coefficients in this system of equations must be 0 for consistency. So let's apply this rule and see what we'll get. So let's form the coefficients determinant matrix. So you have 3 for this one, and you now have 1, and you now have 2 over here. Then you now have 4, you have 2, you have -1, you now have 2 -1, you now have 3k. So you want to evaluate this determinant and make sure that the value of this determinant is 0. So this will enable us to determine the value of, okay, this is a minus k, sorry, to make us determine the value of k for which this system is going to be consistent. Now, unlike the method that I used to solve the previous problem, that's the first part of consistency, that method might be a little bit too long or longer than usual, or if you're not very familiar with row operations, you might not really be comfortable with that method. But if you understand it, it's a plus for you. But I'm just here to show you another better way, okay, that you can use to approach questions on consistency. Take note, as usual, these systems, we have two variables. Okay, that's two variables, x and y, x and y. So two variables, three equations. So two variables normally supposed to have two equations for us to solve it simultaneously. When you're given two variables and three equations, if you express it in this particular form, then if you want to test for consistency, you have to make sure that the determinant of the coefficients matrix, okay, when you make sure that you arrange everything in this form, that means all the right hand side should be 0. You push all the constant terms to the left hand side. So when you arrange it in this form, then the determinant of your coefficients matrix should be equal to 0. So in doing that, you will now be able to what? Test for consistency. So how do we solve these determinants? Normally someone will want to open from here, here and here, but this time around you have to know that in matrices you can be flexible as much as possible. I'm going to expand this determinant on the third column. So remember, this is plus minus plus minus plus minus, then plus minus plus. So I can expand my determinants anywhere I want to expand it, apart from diagonally. You can expand from any row or from any column you want. So I'm going to expand along this particular third column, because this third column contains my k elements, and to make it easy for me to evaluate it. So see what I'm trying to say. So if you expand this determinant, what you're going to get is, starting with this element 2, then the minor of this 2 is going to be, of course, you can say it will be 4 2 2 minus 1. Okay, then you go to this one. Since it's a minus, you have minus k into, then if you find the minus of, that's the minus of minus k, the minus of minus k is going to give me 3 1 2 minus 1. Is that okay? That means you put a cross on this row and on this column. There, now check this, check this, check this, check this. Then we now go to plus 3k. Okay, so what are the minus of plus 3k? So evidently you have 3, you have 1, you have 4, and you have 2. So we equate everything to 0. So let's solve. We have 2 into, evaluating this, I'll have -4 minus 4, plus k into, this time this is negative 3 minus 2, and plus 3k into 6 minus 4 equal to 0. So evaluating this, you have 2 into minus 8, and you now have plus k into minus 5, and plus 3k into what? 2 equal to 0. So if you solve, you're going to have minus 16 minus 5k plus 6k equal to 0. On solving, you get minus 16 minus 5k plus 6k is plus 1k. So if minus 16 plus k equal to 0, the implication is that k is equal to 16. So for this system to be consistent, the value of k has to be 16. Okay, and you got that by making the determinant of the coefficient matrix of this system to be equal to 0. So that's all about this method. I'm going to give you a challenge. You can actually put this method to the test in the other problem that I solved earlier, in consistency problem 1. Put this method to test and see whether you get the same answer for the values of your k. So give me a comment in the comment section once you're done solving that. Thank you for watching, and see you in another video. Bye.